are going to look at another way that we can solve quadratic equations. This is when we are missing the middle term, which is bx. So if we want to solve negative 16x squared plus 500 equals 0, there are two different ways. So the other day we learned how to solve the quadratic using the quadratic formula. And so that is when a is equal to negative 16, our b value is equal to 0 because that's the bx value, and our c is equal to 500. So we would write our quadratic formula, which is x is equal to negative b plus or minus b squared, the square root of b squared minus 4ac all over 2a. And then we go plug these in, and this is what we call the long way, when the bx is 0. So x is equal to, the b is negative 0 plus or minus the square root of b squared, which is going to be 0 squared minus 4 times negative 16 times 500. Whew, that's a huge number. All over 2 times negative 16. Then x is equal to negative 0 plus or minus the square root. We have 0, and then we'll probably go ahead and put this into our calculator or see if we can do that. So we'll have 4 times 16 times 500, a negative, we know which is going to be positive. This is going to be 2,000 times, so 2 times 16, which is going to be 32, and we add some zeros all over that, all over a negative 32. And then x is equal to negative 0 plus or minus 32,000 all over negative 32. And then we want to go ahead and we're looking for the biggest number that can go into 32,000. So you probably might want to go ahead and pick up your calculator and put 32,000 divided by x and see what your perfect square is going to be. And so x is equal to negative 0, and I know that that is going to be, let's see if I can help you out, just to refresh your memory. And so you'll do 32,000, divide that by x, and then we're looking for Control T, and then we're looking for these values right here to see what is the biggest perfect square that will go into each one of those. And let's see what you can go ahead and find. And so I know 6,400 is going to be a perfect square, and so 6,405 will be what I'm going to end up with. And so that is going to be, if I rewrite that, plus or minus 6,400 times 5, take the square root of each one of those. And I'm out of room, so I'm just going to put that over here. And so then I'm going to have x is equal to 0 plus or minus, and then that's going to be 80 square roots of 5 all over negative 32. And so then we can go ahead, and so I don't have to have the 0 right here. So now we're going to break that down into reduced radical form, which is plus or minus 80 square roots of 5 over 32. So we want to go see, can we go in and take anything out of the 80 and the 32? And yes, we can. And so when we go in and do that, we can go ahead and reduce that. We can take a 16 out of that. And so when we take 16 out of that, that becomes a 2. And we take a 16 out of 80, this becomes a 5. And so x is equal to plus or minus 5 square roots of 5 all over 2. And so that's how I will write my answer as 5, as a plus or minus 5 square roots of 2. So that means that my answer for x is equal to 5 square roots of 5 all over 2, and x is equal to a negative 5 square roots of 5 all over 2. But I would prefer that you write your answer as plus or minus 5 square roots of 5 all over 2. If we're looking to see what our answer is as a decimal, because sometimes we have to know what it is as a decimal, so we would put it in the calculator. And so we would go ahead and put 5 square roots of 5. Actually, what we would do is we would hit Control Divide and put 5 square roots of 5, and then put the 2 on the bottom, and that's going to give us 5.59. And then we would hit Control Divide, and we would put a negative 5 square roots of 5, and then we would put a 2 here, and that's going to be negative 5.59. So you can see that these are actually the same number, but I just wanted to show that to you. Okay, so then x is equal to plus or minus 5 square roots of 5 ninths. So this was the long way, and so we want to find a shortened way when the b value is gone. And so I'm going to show you what we call solving by square roots, or hopefully you're going to think, oh, this is the genius way. And this is if I'm missing the b value. And so that's when bx is equal to 0. So I have a negative 16x squared plus 500 is equal to 0. So what we want to do is that we want to get the x squared on one side, and we want to get your constant on the other side. So I'm going to move the 500 to the other side. So I have a negative 16x squared is equal to a negative 500. Then I'm going to solve for x squared. So I'm going to divide both sides by negative 16. And so then I have x squared is equal to, and then we can reduce that. And so you can put that into your calculator to reduce that. So you can put 500, and then you can put the 16 on the bottom. And that's going to reduce down to, so we have x squared is equal to 125 all over 4. And so then we want to get x by itself, so we have to take the square root. And so when we take the square root, we take the square root of the top, and we're going to take the square root of the bottom. And so then x is equal to, and then we're going to break down the square root of 125, and then we already know the square root of 4 is 2. And so we're looking for the largest perfect square that goes into 125. And so we know that that's going to be 25. And that's going to be 5 all over 2. So x is equal to, and then when we're taking the square root, we're going to have a plus or minus. So this is going to be plus or minus 5 square roots of 5 all over 2. And the reason that we have our plus or minus is because when I'm looking for the square root of 4, that is going to equal 2 times 2. When I'm looking at the square root of 4, I also know that is going to be a negative 2 times a negative 2. So there's two numbers that will give me a positive 4. 2 times 2, which is equal to 4, and a negative 2 times a negative 2, which will also give me 4. So we don't normally take the negative, but we're looking for a positive or a negative. Okay? So that's the reason why, because 2 times 2 will give me 4, and a negative 2 times a negative 2 will give me 4. All right, so we're going to solve each equation by the square roots. If now possible, we're going to use our calculator. So I look to see that I do not have the linear term, so I divided both by 6. And so I ended up with 275 divided by 3 as squared. We're going to write this as a decimal for this purposes. And so we're going to have s is equal to plus or minus, and we're going to take the square root of 275 divided by 3, and that is going to be plus or minus 9.57. All right, so looking at the next one, and we have 61 minus 3n squared is equal to negative 41. And so we're going to go ahead and bring the 61 over on this side. So we're going to subtract 61. And so we'll have negative 3n squared is equal to negative 75 divide by negative 3, and so we'll have n squared is equal to 75 divided by 3 is 25. We'll take the square root of both sides, and then n is equal to, we put a plus, a minus, and the square root of 25 is 5. Letter C, we're going to move the constant over, so we'll add 9 to both sides. And so we have 1/2 x squared is equal to 16. I want to get rid of this fraction right here. So to get rid of that fraction, I'm going to multiply both sides by 2. So we have x squared is equal to 32. We're going to take the square root of both sides. And so we'll have x is equal to, and this is something that we can go ahead and simplify. And so see if we're going to have it as the plus or minus the square root of 32, because this is going to be 2 times, look to see can we simplify that, and that's going to be 2 times what will give us 32. And so we cannot go ahead, and this is going to be 2 times 16, so we can go ahead and simplify that a little bit more. And so this will be plus or minus 16 times 2, and so x is going to be plus or minus 4 square roots of 2. We can also go ahead and put the square root of 32 in the calculator and get a decimal for that. Square root of 32 to get a decimal, and that is going to be 5.66 plus or minus 5.66. So we have both the decimal and the simplified radical. So if you can, you simplify the radical. Now this one over here, when we have the square root of 275 over 3, we could not reduce that any further because we cannot have a radical. We can't take the square root of 3 because we can't have a radical in the bottom. So that's why we left this as a decimal. So 3x squared plus x minus 14 is equal to 0. And so there's a couple different ways we could go ahead and solve this, because this is not the genius method. We can go ahead and use the quadratic formula. Or the notes say to go ahead and use your graphing calculator. And so I'm going to use my graphing calculator to go in and find what my roots are. And so to refresh your memory, you're going to go to number 2. I'm going to type in 3x squared plus x minus 14. Hit enter. And this is what our parabola looks like, and we're looking for these values right here. We're going to press menu, and we're going to press analyze our graph, and we're going to look for the zeros, and we're going to move this line over until we can go ahead and hit a 0. And this tells me that one of my 0 is 2, 0. And then I'm going to do that again, menu, 6, 1, and I'll bring the graph over here, that little dashed line, and then move it over, and that will tell me my other, which is going to be negative 2.38. And just a reminder that when we write our zeros, that we'll write it like this. Put them together. All right, looking at letter E, 25x squared minus 4x is equal to 0. So this has a linear term, so I cannot use the genius method. So I can go ahead and find my zeros. I could put it in my calculator to graph it, or I could go ahead and I can factor to see what happens with that. So I factor out my GCF, which is going to be x, and so then I'm left with 25x minus 4, which is equal to 0. I split it, so x is equal to 0, and then 25x minus 4 is equal to 0. And so I know this is one of my x-intercepts. Add 4 to both sides. So 25x is equal to 4. Divide by 25. And so then x is equal to 4 over 25. And then I would just go in and get a decimal just so I can see where that is. And this is going to be 0.16. And so that would be 0.16 for my decimals. Or not my decimals, for my solutions. All right, so the next one. So an object that is dropped from a height of 200 feet can be modeled by the equation h equals negative 16t squared plus 200. How long will it take for the object to hit the ground? So my question is, when does it hit the ground? So if you were to draw a graph, we already know that this right here is our y-intercept. And when it talks about hitting the ground, this right here is our ground, and we know that this is going to be our x-intercept is what we're looking for. So we have something that we know is going to be downward, and we know that this right here is 200, and our graph is going to look something like that. So this is our y-intercept, and this is going to be 0, 200. And since it's dropped, it's not going to go above 200, and it's going to stop here. So we're not going to be looking for any values over on this side. That's the extraneous data. We're just basically looking for this quadrant 1. So this height over here is when it hits the ground, what is going to be the height? So the height when it hits this ground is going to be 0. Excuse me. So we're looking for how long, so we're looking for time. We do not have the linear function, so we can go ahead and solve this by the genius method. And so I can either move the 200 over, or I can move the negative 16t squared over. It doesn't really matter. So I'll move the 200 over. And so I have a negative 200 is equal to negative 16t squared. We need to get the t by itself. So t squared is equal to, and then we can go ahead and reduce that down. So you put 200 divided by negative 16. And that is going to reduce down to 25 all over 2. Take the square root. And so t is equal to, and then since we are talking about time, I do not want this as a radical, because when I go say what time it is, I'm not going to say, oh, it's the square root of 5. I need this as a decimal if I'm talking time. And so I will go in and put that in the calculator. Square root of 25 all over 2, and that is going to be 3.54 seconds. And yes, I have my label. So remember that if you're talking time, or if I'm talking length and stuff like that, I'm going to go ahead and put it as a decimal. So that's 3.54. Sean launches a toy rocket in his backyard. The path of the rocket is modeled by the equation h equals 16t minus 3t squared. So here's our equation that they gave us, where h is the height in feet, and t is the number of seconds since the rocket was launched. How long will it take for Sean's rocket to hit the ground? So we're looking for when will it hit the ground. And so there's no plus 0, so we're assuming that it's starting here. It goes up and it's going to come down, is what our graph is going to look like. And we want to know, what is this time right here when it hits the ground? Well, when it hits the ground, the height is 0, so we're going to set this equal to 0. So 0 is equal to 18t minus 3t squared. So we have lots of options that we could go in and work this, but we do have the b value, so we cannot solve it the genius method. And so I'm going to factor out the greatest common factor. And so I'm going to switch these around so that I can get my t to be a positive, so I'm going to bring this over here. So I'll have 3t squared minus 18t is equal to 0. So then I'll factor out a 3t, and when I pull out a 3t for all of these, I'm going to have t minus 6 is equal to 0. I'll split these, and so 3t is equal to 0. T minus 6 is equal to 0. Divide by 3, and so this time is equal to 0 seconds. Add 6, and my time is equal to 6 seconds. So this is the first y-intercept. So how long will it take for Sean's rocket to hit the ground? And so it's going to start at 0, goes all the way up, reaches its vertex, comes down, and it's going to come down. It's going to be in the air for 6 seconds. All right, so looking at your homework, I believe this is question number 7. So a student launches a model rocket. The height of the rocket, h, in feet after t seconds is given by the function h equals negative 16t squared plus 16t plus 4. Identify the range of this function. So basically what you have to do is you have to look at the highest point. You want to identify what your max is. And so what we're going to do is we want to go ahead and figure out what is going to be our highest point for that. And so for this one, we have to go figure that out, and we have to list A, our B, and our C. In order to do that, we have to go find our axis of symmetry. And so our A is negative 16, our B is 16, and our C is 4. I lost my pen, so hopefully you can see that. And so we're going to use our axis of symmetry equation, which is x is equal to negative b all over 2a. And so x is equal to negative 16 all over 2 times negative 16. X is equal to, so you can see that they are going to cancel out. So x is equal to 1/2. So my axis of symmetry is at 1/2. X equals 1/2. This is also the x value of your vertex. And so now you're going to go plug this into your equation so that you can find your y value, which is your highest point. So then y is equal to negative 16 times 1/2 squared plus 16 times 1/2 plus 4. I'll give you a second to go off and do that. And then that's going to be y is equal to 8. So on your graph, you know it's going to open up. It's going to open down. This right here is your y-intercept. So it's starting at 4. It goes up. And it's going to come down. It's going to stop. It's not going to go down here at all. We're not interested in anything that has to do over here because we can't have negative time. And so you're just looking at right here. This is your axis of symmetry, and you want to know what is your highest point, because you want to know what is your range, and your range is going to be all this value right here. And we just identified that as 8 right there. And so your range is going to be all these points from here on down. Your rocket's not going to go in the ground. It has to stop at this 0 point. So hopefully that's enough information for you to go in and write your range.